welcome to chapter 2, and welcome again to a very small space. The Earth, as we saw in chapter 1, is a closed mass system. It's a closed biological system, and therefore you have to be careful to respect its boundaries, these planetary boundaries. And in the last session, we saw that temperature was one of the basic organizing elements of all of life on Earth. Now this chapter, we're going to zoom in a little bit more closely into something called tipping points. Chapter 1 hopefully made clear the urgency of climate change education. Climate change is about a systemic failure, like having a flu at 2 degrees or 3, or hyperpyrexia even at 4 degrees. So that's like the systems level threat that we're facing. Now this chapter, like I said just before, is zooming in on some of those critical moments in the heating up of the Earth's atmosphere. The best starting point for understanding tipping points is probably to think about the game Jenga. That starts by building a tower of wooden bricks, and you make them very compact, make them very stable. And this process takes a little bit of time, and you can imagine that that compact solid tower that you start with is a bit like the 4 million years of evolutionary history, which has given us the planet that we inhabit today. Of course, in the game, what happens is that different bricks are taken out and the tower becomes more and more unstable. And then at one point, there's one brick which you take out. It's not different to the other bricks, but that one brick is the key difference between it being stable and it being chaotic and disordered, and you get a sudden change. So let's move away from Jenga bricks and abstract definition, and let's actually look at what this is like in the real world. Here's a map of the world, and on top is transposed different elements of the Earth's system. In the north and the south, we have Arctic ice and Antarctic ice. We have the Amazon rainforest, and we have the jet stream. And each of these components over millions of years has settled into a kind of pattern with each other. Now, if any one of those elements destabilizes, it could trigger the destabilization, or more likely trigger the destabilization of many other elements. And this is the great fear that climate scientists have with pushing the Earth's temperature over 2 degrees. And I think the best way to illustrate this is to just have a look at a bike race. As you can see from this slide, the line which goes up represents the increasing danger of those components of the Earth's systems destabilizing. So if we start at the very top with the permafrost, the amount of methane which is contained inside the ice in the Arctic regions, if that was to be released by the ground defrosting, then that would take the level of carbon dioxide or equivalent in the atmosphere to levels which are way beyond what we have now, from 400 parts per million, or 420, into the over 1,000. So the permafrost which would be triggered at 4 degrees, the collapse of the permafrost at 4 degrees, would be a decisive moment in Earth's history, and for sure human history. The Earth would essentially become pretty much unrecognizable than the Earth systems which we have today. Now, just one step down from that, you have at 3 degrees the Amazon rainforest, and scientists understand that that will collapse at 3 degrees. Of course, it depends how long the 3 degrees is sustained, and it depends on our deforestation of the Amazon rainforest and other things. But as a broad summary, the Amazon rainforest is not looking good if we heat the global temperature to 3 degrees. Mark Lynas' excellent book, 6 Degrees, maps out for us, chapter by chapter, degree by degree, what kind of scenarios we might expect at those different temperature rises. And I wouldn't recommend you reading chapter 6 before going to bed, because it's not an Earth that resembles this one at all. But those catastrophic effects are not just limited to going over the 2 degree line. There are some things in play already at the smaller temperature rises which are catastrophic for some people who are dependent on smaller ecosystems or smaller components of these Earth systems at that temperature. For example, at just 2 degrees, the glacier that feeds the River Rimac is doomed. And that's a big deal if you depend on the River Rimac for your fresh water in the summer. And that's in fact exactly the case for the roughly 10 million people that live in Lima in Peru. Indeed, the glaciers in the Himalayas and the Hindu Kush, they provide fresh water for over 2 billion people. And as you see in this scientific report, there are extreme consequences of global warming temperatures of just 1.5. So with the help of the Guardian newspaper, you have a graphic to illustrate some of the possible scenarios which could play out with different levels of warming. With an average 1.5, a third of the ice in the Himalayas will be lost by 2100. With a warming of 2 degrees, we have half the ice lost by 2100. And with more excessive warming of 4 or 5 degrees, we end up with 2/3 of the ice lost by 2100. The author of an important report published in 2019, Philippus Wester, said this. He said, "This is the climate crisis you haven't heard of. In the best possible worlds, if we really get ambitious in tackling climate change, even then we will lose 1/3 of the glaciers and be in trouble." And this for us was the shocking finding. The point is that we cannot be destabilizing these systems which we have built our human civilization on. It's just not possible to understate the importance of understanding these things so that we can pass proper legislation, have proper investments in infrastructure, and just get on with treating this as the emergency which it is. And here is the really weird thing. Human civilization, although it knows the dangers ahead, the minefield of tipping points that lie ahead of us, we are not that attentive to exactly how close we are to crossing the line. There is no carbon index. There's no consistent media attention on how much of the carbon budget is left for 1.5 and for 2 degrees. And this is the topic of the next chapter.